Welcome to this explainer. It's funny. We walk on the ground every single day, and it's so easy to just assume it's this uniform, endless block of brown dirt going all the way down. But actually, that couldn't be further from the truth. There is an entire, hidden, highly structured world right below us, functioning as a complex system that keeps our planet alive. So today we're going to grab our imaginary shovels and unpack exactly how this underground architecture works. Okay, let's dive into this. Here is our roadmap for today's descent. First, we'll open up the soil history book. Then, we're digging down through the specific horizons. After that, we'll look at real-world soil applications. And finally, we'll wrap up with protecting our vital topsoil. So, part 1, the soil history book, starting with a roadside discovery. To really get a feel for this, let's look at a great anecdote from our source material about a student named Amma. So Amma was visiting a road construction site, right? Heavy machinery had literally sliced right through a hillside. And looking at that newly exposed earth, she noticed something super fascinating. The dirt wasn't just one color. There was this distinct band of dark topsoil right at the top, then a thick, striking band of reddish subsoil right below it, and finally, this hard, rocky material at the very bottom. As her teacher pointed out, these layers aren't just random color changes. They actually have completely different chemical properties and biological functions. It just brilliantly illustrates how nature systematically organizes the soil. In fact, think of the soil profile as a history book, showing exactly how that soil formed. Every distinct band of color and texture we see when we slice deep into the earth, it's essentially a different chapter in the planet's geological development. Just like reading a book, top to bottom, reading the layers of the earth tells this amazing chronological story of weathering rock, organic breakdown, and just immense stretches of time. Let's formally define what we're looking at here. A soil profile is a vertical section of soil showing distinct horizons. When we say vertical section, I want you to picture slicing a massive geological cake all the way from the grass down to the solid rock core. The distinct horizontal bands you see in that slice, those are called horizons. Having this clear definition is absolutely crucial before we start doing the heavy digging. Let's move to section 2 and see how this builds. Digging down, the horizons. We're going to explore O, A, B, C, and R. So, there are 5 master horizons we need to know. Starting right at the surface, we have the O horizon, which is the organic layer. Next is the A horizon, known as topsoil. Then the B horizon, our subsoil. Below that is the C horizon, the parent material. And finally, the R horizon, which is the bedrock. You're definitely going to want to remember this specific order. O, A, B, C, R. It's a sequential journey from the very surface down to the deepest unyielding stone. Let's explore what makes each of these unique. Let's start right at the top with the O and A horizons. Now, what's really interesting here is that people often mix these two up, thinking they're the exact same thing, but there is a huge difference. The O stands for organic. This is a super thin top layer made almost entirely of organic matter and humus. Think freshly fallen leaves, decomposing twigs, stuff like that. But right below that is the A horizon, the topsoil. The A horizon is dark, incredibly fertile, and just absolutely packed with living organisms. It's basically the bustling, living city of the soil world, where insects and roots thrive in a mix of minerals and organics. The O layer is really just the organic blanket resting on top of that living A layer. As we keep digging down past the topsoil, we hit the B and C horizons. The B horizon is the subsoil, and you can think of this as the storage zone. As rainwater filters down from the top, it carries dissolved materials with it. This means the B horizon gets totally packed with accumulated clay and minerals. Then, below that dense storage zone, we find the C horizon, which consists of partly weathered parent material. It's basically a transitional zone. Down here, the solid rock is just starting to physically and chemically break apart. You really won't find plant roots or insects hanging out down in the C horizon. And finally, we hit rock bottom, literally, the R horizon. Solid bedrock. The R simply stands for rock. This is the foundational parent rock for the entire system sitting above it. Over immense periods of time, this massive, unweathered stone crust breaks down to form the C horizon and contributes to the mineral makeup of the entire soil profile. Okay, moving on to section 3, real-world soil applications, beyond the dirt. Studying the soil profile is absolutely critical for huge, real-world land management decisions. Farmers, for instance, rely heavily on understanding these horizons so they can choose the right crops. Plant roots actually need the right depth of A and B horizons to survive. Engineers, they absolutely have to assess the depth of the bedrock and the stability of the subsoil before they pour foundations for skyscrapers or pave highways. I mean, if you build on a shifting horizon, a road could literally collapse. And of course, environmental scientists study these land resources to track pollution and manage really delicate ecosystems.
All right, let's pause for a quick knowledge check to see how well you're tracking with our geological descent. Pop quiz. Which horizon contains humus? Take a second and picture the layers we just talked about.
If you guessed the O horizon, you hit the nail on the head. It's that very first, topmost layer made entirely of decaying organic material and humus, resting gently right above the topsoil. Let's do one more just to lock this in. Pop quiz. Which horizon stores accumulated clay and minerals? Think about the layer where water washes all those heavy materials down into a deep storage zone. It's the B horizon, the subsoil. Awesome job if you recalled that. Remember, the B horizon acts like a giant, dense mineral catch basin right underneath the bustling topsoil. Which brings us to our final section, Section 4, protecting our vital topsoil. Why the A horizon matters. Fertile topsoil, our A horizon, is fundamentally essential for life on Earth. It's the primary support system for crop production, giving us the exact balance of nutrients needed to grow the global food supply. It also supports immense biodiversity. A single handful of healthy topsoil houses billions of microscopic organisms, insects, and vital fungi. Plus, it plays a massive role in water retention. It acts like a giant sponge that prevents devastating floods while holding onto moisture for plants during severe dry spells. So the crucial point we need to take away from this is that erosion that removes topsoil greatly reduces soil fertility. When harsh winds or heavy floods wash away the A horizon, we aren't just losing some brown dirt, we are losing the living, breathing engine of the entire terrestrial ecosystem. The clay-heavy B horizon and the rocky C horizon below simply can't support agriculture in the same way. Once that topsoil is stripped, the land's ability to produce food plummets drastically. To really put the fragility of this system into perspective, I want to give you a staggering number. Hundreds. According to the data, it takes hundreds of years for just a few inches of healthy topsoil to form naturally through the painstakingly slow breakdown of rocks and organic matter. Think about that. Hundreds of years to build what poor farming practices or a single severe storm could wash away in an afternoon. It truly elevates the dirt under our feet to one of the most precious natural resources we have. Which leaves us with this final, provocative question. Why should topsoil be protected more than subsoil? Thinking about the complex biological processes we've explored today, the fragile life it supports, and the immense time it takes for the Earth to write that specific chapter of its history, I really encourage you to ponder the environmental implications of the world beneath your feet next time you step outside. Thank you so much for joining me for this explainer. Keep asking questions and keep exploring.